All right, hello, Alan. We're talking about you. All right, so here's, let's see if we can, thank you for closing that door. Let me tell you where we're at, and then you say, well, I guess we did something before I left for Christmas break. You guys did a great job on the titration. I really liked it. What I haven't seen yet is I haven't seen the results. So I'm probably going to put a little place on the board here, and group 1, group 2, if the 6 groups, sometime by the end of the day, I would like to know, you had a trial, a practice run, then you had 2 real runs, right? I would like you to calculate the molarity of the acid on the 2 real runs, you get that? And take the average, and then put up here before the end of the period what it was, what you think the molarity of the acid was. And then we'll have a discussion about that too. Now, does everybody have this paper with them? Everybody have that with them? What we're getting ready to do now is part 2 of the titration lab, which the part that you did, the classic titration with the phenolphthalein and that has been done over 100 years, probably 150 years. They've been doing titrations like that. Remember, you were supposed to be doing some research. This project said research is part of the thing you're going to turn into me by the end of this week. Now, do you understand? You can do titration. We did acid-base titration, but you could titrate looking for the chloride ion. You could actually do different kinds of titrations, but it's still the same idea. You take a known or standard solution and let it react with an unknown, and you'll be able to discover something about the unknown. Is that right? That's kind of what titration is all about. Now, what you had done, I had actually done, but it wasn't until probably around 10, 12 years ago, they had LabQuest, and we had LabQuest here earlier than a lot of schools. At that time, they had this thing, the annual fund. At that time, annual fund was only for extra things. If you needed more band equipment, and so I was able to get LabQuest 1 through that. Now, they were supposed to last about 5 or 6 years, and we had them for 10. And so we were having a lot of trouble last year and the year before, and sometimes it got to the point where only 2 of the LabQuests were giving us good data, and we still plunged through it. And anyway, I took a chance, and I asked Mr. Schilling about, hey, these are like, these are LabQuest 2. And he looked in the budget, and he said, okay. So we end up getting, we have 8 more of these LabQuests. So we have LabQuest 2. Now, so that's the good news. It should work better. And you're going to store data here. You're going to print it. We're going to print the data. You can store it. You can do calculations on here. And I shouldn't have as many technology problems. That was what was eating up our time. We're having so many technology problems. Okay, I said, okay, can you start it, stop it, start all over, let it reboot? Can you replug it in, get a different laptop? I was getting to the point where you were doing everything you could think of just to make it work. And I think it's going to be smoother this year, okay? All right, right here, here's where we're going. Now, I know, did everybody finish? Do you think you kind of finished what you need to finish? Did everybody get both runs done? I thought we did. Okay. By the way, it's interesting. I thought about doing a little field trip where everybody goes and visits every table, and I go look at it, and you see who actually is a good chemist, because some of your tables have all kinds of white rings on it. And what do you think that is? What do you think that is? When you see like a white ring and circle here, and if I put phenolphthalein on it, it'll turn purple. What do you think that is? That's NaOH, isn't it? And then see that drying rack there? I don't forget who's at that table back there. You don't have to say anything. But if you're at that table back there, shame on you. You put a beaker in the drying rack, and look what's right underneath that beaker? White. So you put a pretty contaminated beaker on a drying rack. So whoever that is, when you get ready to clean up your table, you clean off your table, get that beaker out, clean it again, clean the drying rack. See that? You don't put it on a drying rack if it's contaminated. Get that? So that's the one good thing about NaOH I can actually tell. Now this table here, I purposely told them to leave a drop of NaOH over there, and so you can see what it looked like. Is that still there? You see like a white circle? Yeah, okay. They want to know what, let me see, I actually put it on there. So let the water dry out and you'll see the NaOH. So, okay, but anyway, when you get back to your table, you check it over and said, maybe we could be a little better at this, all right? All right, so here, we're starting phase 2 of this, and until about 10 years ago, I had never done this. Not in college, certainly not in high school, not in college, and I only remember seeing this graph once in a college textbook, but it didn't mean very much to me because I'd never done it. You guys are going to be doing a titration with electronic or sensing devices. So you're going to have a pH meter that is electronic. Everybody get that? Now you're going to, what you'll do is it plugs into LabQuest. Now LabQuest, I don't remember, I think we had some of that in physics. Did you do a little bit of that in physics? I don't think COVID had hit. I think, did we do some LabQuest? Okay. Yeah. So anyway, it's kind of like, it is a computer. It's like a little computer. As a matter of fact, it has about, I don't know, 50 labs. I could actually do a lab at this. And it also has the little ports here. And these are analog ports here. We have some digital ports here. But I charged them up, but I'll probably go ahead and give you the plug-in anyway, because I don't want your power to run out just at the wrong time and like that. So I'll probably give you the plug-in and all that. But what you're going to be doing is you're going to do the same experiment, and you're going to have your stir station, and now you're going to use a pH probe. And the pH probe is electronic, and what's going to happen is it's going to sense what the pH is. So you're going to start it, and you're going to, and the directions are here. That's the good news. All the directions are here. So I want to go over a little bit of this. Let's see. This is the equation you used before. You're going to get a graph that looks something like this. Now, what's going to happen is when you do a titration, I had never seen this in my life until about 10 years ago, real time. You guys are going to be seeing this on the screen. You'll see your first data point, and you'll say, hey, I put some NaOH in there, but the pH didn't change at all. It seems like it's not changing. It doesn't look like it was changed a tiny bit. And then you'll get kind of bored. Okay, you got to be careful about getting bored, because what's going to happen when you get to about here? See, you might add 10 milliliters here, and it changes a little bit. The pH changes a little bit. Get that? And then you'll get kind of bored, and then you'll get here, and you'll think, oh, I had 10 milliliters. Whoop! Okay, when you get from here to here, it might be 1 drop. You could have 1 or 2 drops that could make that change. You get that? So you have to be ready to do what they tell you to do. And when you see the graph starting to do that, then you slow down. You slow down. And you might put a drop or 2 drops and then 1 drop. And then you still have to let the curve flatten out a little bit. So the minimum is here and here, okay? So you're going to get this S-shaped curve. And this is the typical what they call strong acid, strong base titration. All right, now the reason I need the curve is that we need to find somewhere in here, it's called the equivalence point. Now, what you guys, you know that in your packet, when you turn in your project, remember you have to have a list of vocabulary words? Vocabulary words, anybody did a titration, these are vocabulary words you would use. Do you remember seeing the word equivalence point? Is somebody in your group in charge of vocabulary words? Okay, look, equivalence point is one of them, but endpoint's another one. What's the difference between endpoint and equivalence point? Does anybody happen to do any research on that? Tim, do you have your thing with you? Might want to get that out real quickly. Okay, so when you use phenolphthalein and it changes color, that's called the endpoint, the visual endpoint. But what you're doing here is you're going to figure out electronically electronically when neutralization really occurred. It's just a coincidence that phenolphthalein changes close to the neutralization point. You get it? And that's what your goal. I still want you to put phenolphthalein in here, even though they don't tell you to. I want you to put phenolphthalein into this next run because I'd like to know when the phenolphthalein changed, how much NaOH did it take for the endpoint, and then you're going to calculate how much NaOH it took for the real theoretical equivalence point, the real point where it was absolutely neutral. And I'd like to know what the difference is, all right? Yes?
Is the phenolphthalein what makes it change color? Is that a chemical change?
Is that what?
Is that a chemical change?
Okay, great question. Now, yes and no. If you look this up, you'll see the structure of phenolphthalein when it's in an acid environment, and then you look up this, and I'll even give you extra credit. Give me a drawn-out structure of phenolphthalein in an acid environment and a drawn-out structure of phenolphthalein in a base, and you'll see that it gets bent a little bit, and it actually, for whatever reason, that bend makes it change the color, produce a color. So if you can find the structure in an acid environment and in a basic environment, I'll give you credit for that. That's a great question. So in a way, it is a chemical change because you have an acid and a base neutralizing that chemical change. But you're talking about is phenolphthalein. It's actually still phenolphthalein. It's just phenolphthalein bent or phenolphthalein this form of phenolphthalein. So is that a real chemical change? Maybe. I might say yes on that. But it actually is still there. It's still phenolphthalein. It can bend back. Great question. All right, so anyway, so how do we find the electronic equivalence point like that? So let's go over here, and here's what's going to happen. And the reason I want to talk a little bit about this today is because if you don't get started right away tomorrow, you will not finish, okay? So I'm going to ask you, say, I know you just got back to school. When you go on Google Classroom tonight, there are a couple of 3 or 4 minute videos. If you can watch those, it won't take very long, you'll be a little bit more ready for tomorrow, okay? And but anyway, let's talk about this. Again, you don't have to use a pipette. If you're really good at the volumetric pipettes and the pipette pumps, you can do that. But I think you're really pretty good at using the graduated cylinders are almost as accurate, almost. They're very, very close. So you don't have to use a pipette if you want to do the way you did it before. And I think we did 50. I think I'm going to cross that out. Let's do 40. How about that? Can we do 40? Is that what you did before?
I think we did.
Did you guys, didn't you use 40 for the real ones? Okay, so let's cross that out and go with 40. Matter of fact, I know how much I have left. And if I only give you 40, I should have enough. I should have a little bit left over. So don't make too many mistakes tomorrow, okay? All right, now. Anyway, you're going to do the same thing you did. You have your stir station. You're going to put an exact amount of unknown acid in there. And somebody else is going to be loading up the burette. And since it's been like a couple weeks, remember how you put a little NaOH in there and, you know, kind of coat the sides and let somebody come out trash beaker. Do you remember some of this stuff? Okay, then it's all ready to go and you do your reading. He said, let's get ready to start. And then, so everything else is normal. And I do want you to put phenolphthalein in there, even though it doesn't say that. Anybody know how to spell that word? Anybody know how to spell phenolphthalein? Wow, look at that. You'll never see that in a word. Okay, so I do want you to put phenolphthalein in there because I would like you to note somewhere in your report, when we did this one, the phenolphthalein changed with 135 milliliters of NaOH, but the electronic equivalence point said it was it took 138 or something like that. Okay. Okay. Now, when you do a LabQuest, if I just open up LabQuest and I just turn it on like this, and you can plug it in tomorrow, but you might as well turn it on to begin with because it takes about 2 minutes to load up all the stuff. It's got a lot of stuff in memory. And so just leave it sit there, and then eventually you're going to go get your material and all that. And eventually I'm going to see these laptops. We're going to be using these laptops. Right now, they are the weakest technology part. They've been here the longest, and they're the weakest link right now. I'm hoping that we're still going to be okay. These are now strong. Now, these are older computers. But eventually what you're going to do is you're going to take this stuff off of LabQuest and you're going to put it into this Logger Pro. A Logger Pro is a program, it's a data crusher. And any kind of experiment you want, you can put the data in there, it'll do this, it'll do that, it'll do all kinds of things. It'll let you put a title on it, it'll let you change the axis, it's just really a valuable thing. So you won't be doing any hand-drawn graphs here on this, okay? Okay, so anyway, so after it comes on, I'm going to show you, can everybody see that? Okay, if you don't do anything with LabQuest, it has a default mode, and the mode is real-time. So if I plug something in right now, it's just going to go, and I say start recording data, it just assumes I'm a second, 2 seconds, 3 seconds. See that? That's the default value. You're going to see in here, it'll tell you, and if you forget this step, you'll have to start all over again. It'll tell you to go to mode. Everybody see mode? Okay. Now, on mode, I'm going to see if I can do this without, there you go, without looking at it. Okay, now see where it says time-based? What we're going to do is, we're going to do called events with entry. It can never be a weather person. Okay. Events with entry. Now, what that means is, events with entry means you don't take data until I tell you to take data. You get that? If you do time-based, as long as time goes on, I'm taking data. No, I want you to take data when I tell you to take data. So that's, when they tell you to say, and every year I have one group that forgets to do that. And so you do events with entry, and then let's read on some more a little bit. And there it says mode, see that? So I just want you to know, when you use LabQuest, you either have time-based, that's the default value, or events with entry, which means take data when I tell you to. Okay, then you just follow the directions, keep following the directions, yes?
Do we need to like tell it when we're going to take data, or will we just, if we just start measuring?
Yeah, and actually it won't, right now, even though I'm going to tell events with entry, they're going to ask you what you want your variable to be. And again, it tells you in there, you're going to put like volume of NaOH, okay? And just say what units, it'll be milliliters, like that. So the directions will tell you pretty much what to do. I'm just saying, if you forget that one step, though, it doesn't work. Now, once I say okay here, okay, it's still not going to take data until I press this little green arrow here. Yeah, and that's when you start recording data. And it'll tell you that also. You get that? It'll tell you that also. Okay, so now what you're doing is, if you can get started kind of early, if you can get started within the first 10 minutes, I think you'll be able to finish. You get that? Okay, now, and then you just keep going here. They want to sell you, and I watched some videos on it. It's really neat. It just costs a lot of money. They have their own little version of, they actually have a burette, and as a drop goes through, it breaks an infrared beam, and it actually counts drops for you, and it converts that to milliliters. So you just start it up and just sit there, and it does all the it does everything for you. But I didn't want the school to have to buy that, so that's why I crossed all that out. Okay. Okay. Now, even though this says alternate, yes, we're doing that. Okay, we are definitely doing that, and we're definitely doing that. And what's going to happen is. And I haven't had calculus for about 45 years, so don't ask me too many questions about calculus. But here's what's going to happen. We want to find the place where the slope of that line is the highest number you can get. Now, does anybody happen to know what to do there?
The maximum.
What is it?
Like the maximum number. Use the first derivative equal to 0.
And you'll see some directions, and it'll say, find the first derivative. And what it'll do is, everybody, you guys had calculus, right? So it's kind of like the first derivative will go like this. Okay. So one graph that you have to print is this one, the regular graph. Then the second graph is the first derivative of that, and it's going to look something like that, and you have to print that one too. Now, LabQuest will do all that for you. Get that? You just say, it has all the directions. It'll say, I want to do the first derivative of that graph when you get done. And it'll do it like that. Now they said, you can actually move the cursor right here and find out how many milliliters of NaOH it took to be exactly neutral, exactly, the equivalence point. And then they have another one, which I think is more fascinating. I don't know enough math to do this, but they call D2 the second derivative. What do you think that's going to look like? And that's weird. I got to remember which one it looks like now. It kind of goes like this. I'm going to forget. It's kind of like this. Kind of like that. Anyway, and so what happens is it actually goes like this, but and you're able to zoom in on this and try to find that exact point. But anyway, you'll have 3 graphs that you will turn in, okay? And again, everything's in the directions. You don't have to look at me and say, how am I supposed to know how to do this? Just do what they tell you to do. And then eventually, if you can get that data tomorrow, you should be okay. And you can have all the next day to do your write-up, or even if you need a print or whatever. I'm gonna check these out. I don't think you're gonna need them tomorrow. I could check them out for tomorrow, but I'll definitely check them out for Thursday for sure. Okay, so here's what I'd like to ask you to do. I would like you to be careful when you only have to do one, not 2. You don't have to do one, but I want you to be a little careful because the directions will tell you to put so many milliliters until it changes so much. But if you have the phenolphthalein in there, you'll kind of get an idea when you're getting close. And since you're still using 40 milliliters, won't you sort of know when you're going to get close anyway? So when you start getting close, that's when you start slowing down. And you might take a reading. And boy, I saw one last year. Yes, they came back and spent an extra half hour after class. But man, I saw one last year. They had like 40 data points. I mean, they were so patient. I don't know if you know Landry. I think what's his first name?
Marshall.
What?
Marshall.
Yeah, Marshall. Sorry. He was just obsessed with this lab, and I've never seen that good of data. And he had about 40 or 50 data points, and he had a lot of data points even through here. But they got started a little late, and so he had to come back and finish it. So anyway, I tell you what, if you could just do a good job tomorrow, I'm going to leave you alone the rest of the period, and I'd like you to kind of get in your groups and kind of make a plan of what you want to do tomorrow. And here's what I would do. I would read through the directions today and say, hey, tomorrow when we get here, you set up the stir station. You do this. You get the burette ready. And I think if you have a plan, you're going to be okay tomorrow. Okay? Even the worst case scenario, we have another day after that. Okay, they're going to get in groups right now, so I'm going to turn on.